So we were talking about the domain of a function. We said that the domain is all of the permitted x values. We said if we were talking about linear equations, they had a domain of all real numbers, unless, of course, it's a vertical line. We also said that the denominator of a fraction cannot equal 0. Now we want to look at the domain from a graph. So I'm going to put arrows on here. I couldn't do that when I was graphing. It didn't let me. But this is a line that continues in both directions. So the domain is looking at the x values. That means we're looking along the x to the left and to the right. And we can see that this graph continues in both directions. So the domain of this graph is the set of all real numbers. We can write that in interval notation, but remember what it means. The set of all real numbers from negative infinity to positive infinity. This is the domain of all lines, unless we are talking about vertical lines. Now, let's look at this one. I'm going to put an arrow here to say that it continues up and to the left. But I think I'm going to put a closed circle here to say that it stops at the point 3, -1. So we're looking at the domain. We can see that it's going to continue infinitely to the left. It's going to keep going all the way to negative infinity. But when I go to the right, it stops here. It stops where x equals 3. Everywhere else, I have a graph that will have an x value. But if I go past x equals 3, there's no graph here. So if we're using interval notation, we're using the endpoints. Negative infinity on the left, 3 on the right. Now, does 3 have an open bracket or a closed bracket? Well, 3 is a point on this graph. So we're going to use a square bracket, a closed bracket, because x can equal 3. Let's put arrows on here. So this graph is continuing down, but it's also continuing to the left infinitely and to the right infinitely. What do you think the domain is? It's continuing from negative infinity to positive infinity. All of the x values in between are part of the domain for this graph. Now we can also take a look at the y values. This is going to give us the range of a graph. So let's put arrows on this line again. We're looking at the y values this time. We're looking up and down, and we see that this graph continues down to negative infinity. It continues up to positive infinity. The range for this line is the set of all real numbers. The range for all lines except horizontal lines is the set of all real numbers. Because when I look at this graph, this line here, I can see that there's going to be a graph that corresponds to -3, or sorry, to +1, 1.5, 2, 2.5, 3, 3.5. This graph goes up and down forever. It's going to hit all of those values of y. Now this one, we put an arrow here, we put a closed circle here. How far down does this graph continue? Well, it stops right here, right? This is the lowest point on my graph. What is that? -3, -5? How high up does it go? Well, there's a point here that stops, but then the rest of the graph keeps going up. This graph goes up forever. It doesn't matter that it stops here because there's still part of the graph that's going up. So the range, just like the domain, is always the lowest value to the highest value. It might have open brackets, it might have closed brackets, but we always start with the lowest value. Remember, for the range, we're talking about y values. What's the lowest y value on this graph? It's right here, where y is 5. What's the highest y value on this graph? Remember, it just keeps going up forever to +infinity. Infinity is always round. What about 5? There's a closed circle here. That means y can equal 5. All right. We had arrows on our parabola. What's the lowest point on this graph? Can you see that on both sides it's going down to -infinity? That's the lowest point. What's the highest point? Stops right there. Remember, we're talking about y values. Its lowest y value, or sorry, its highest y value is -2. Infinity's round. -2 is a point on this graph. I think we'll leave the graphs of functions until the next lecture. If you had difficulty with this, I would say print these pages again and see if you can figure out the domain and the range, and then listen to the lecture again. See if you can understand how to find domain and range from a graph.